There you go. Okay, so for this one, okay, what you want to look for, okay, for all of these is like the ist, okay? Ist means optimization, okay? Whenever they say like with respect to time or like if any of your units are with respect to time, a lot of the times that's related rates. So this one, particle moves along with its x-coordinate increasing at a rate of 0.5 centimeters per second. What rate are the particles' distance changing? They're not asking you like ist stuff. They're asking you at what rate changing. That's going to be related rates. It's a little aggressive pink, but that's okay. So 3 is that optimization or related. Number 3 is that optimization or related rates. Optimization. Greatest. What about 4? Yep. Related rates, because it's saying increasing what rate. They're asking you for a rate. So related rates. What about 5? Optimization or related? Related rates. At what rate? That's what it's saying. Changing. They're asking you for a rate. And then what about the last one? Can you turn that off? Okay. What about the last one? Optimization. Yay. Okay. So anyway, look for the word the least. Did anyone get creeped out with that one though? Because it said rate. It said rate in it. Okay. Notice they're not asking you for a rate. Okay. They're asking all these other related rates questions are asking for a rate. I mean, we're asking for a time at which it's the least. The least is what's going to trump how you know it's going to be optimization. So most, greatest, least, maximize. Those are the easy ones, but otherwise, that's how we do it. So I've tried to find weird ones for you. Okay, excited? This one I've been seeing on multiple choice lately. This kind of one. So it says a company sells 60 gift sets per week for a price of $90 each. Their market research has shown that for every $6 drop in price, their sales will increase by 12 gift sets per week. At what price will maximize the company's revenue? Okay, so like I think what's hard with this one is figuring out the equation. Because it's not like a geometry one where you can like draw a picture or anything. You kind of have to like think about like how do you get revenue, you know what I mean? So when you read the last sentence, you have to decide first if it's going to be related rates or optimization, because these ones are usually one of each of them. So is this optimization or related rates? Optimization. Yep, because it says maximize. So we're going to have to do, we have to maximize revenue. So for this first step, I'm going to use R for revenue. I know, I'm so creative. Okay. So like I'm going to do company revenue. I'm just going to go slow with this because I have to like understand what's even happening. Okay. So we're selling gift sets for this much, and then they're talking about every $6 drop in price, their sales increase. So like you have to figure out like what your X is, because like yeah, we have like we don't know how many gift sets, right? But like what changes in the problem or what like affects the answer the most is not really how many. I mean, I guess in a way, but like the price changes when there's a drop in price. So like all my revenue is changing, yes, with the amount of gift sets, but it's more about the cost of them, because they're saying their market research has shown for every drop, your sales increase. Okay, so your X for this one is going to be your drop in price, because that's what's affecting your revenue. Because that's also going to affect how many you sell. So like the drop in price affects the amount of gift sets, if that makes sense, right? So X is going to be the drop in price. Okay. So then now you have to try to think about like, okay, how do I talk about revenue, right? So like, doesn't that make sense? Like, to figure out the revenue, I'm going to be like, however number of gift sets I sell times the price, right? That's how I'd get the revenue. It's like how much I would get from that, right? So, but we have to change this in terms of like a drop in price, right? So for like the step 2, 3 kind of, step 2 is like when we take that information, or actually I use orange. Didn't I use orange? Yeah. This is kind of like step 2 and 3. You kind of have to put them together because we're kind of doing it all at once here. So like for this one, or wait, I did orange was 2. Oh, geez. I was feeling all good about myself. No, we're not working here. Okay, so anyway, so I'm going to change this. I'll have it as, I'm going to write R of X. I don't know, I'm just feeling that because I'm using X, okay? So for the gift sets, okay, we are for sure, for the gift sets part of it, we're for sure selling 60 gift sets for sure. Okay, so we're for sure selling 60. Okay. Now, with every drop in price, that amount of gift sets increase, right? So if I didn't drop the price at all, I would do 60 times 90, right? But to write this as terms of an expression for just the number of gift sets, I'm going to do 60, okay? And then they'll increase by 12, because I'm using this. This is all my gift set stuff. I'm going to do something for price later for every sales drop. Okay, so if I drop it by $6 twice, right, you're going to add in 24. So for the gift sets part of the equation, it's for sure 60 plus whatever more I need. Okay, and then for the price, for that price part of it, you're going to have, it's for sure $90, right? I'm for sure going to get $90 if I don't have a price drop. But what I'm going to have to do is, again, if I drop the price by $6, okay, so drop it means I'm subtracting from that, right? 6x. So this guy represents all gift sets, right? And then this one represents all price, okay? So the gift sets increase with the drop in price, but the price obviously drops by 6. Does that make sense? Is everyone okay with how we set that up? Okay, so now you're going to be like normal, like solving maximum. So you're going to, I would distribute so we don't have to do product rule. I already did this earlier, so 5,400, 720x minus 72x squared. And then what you're going to do is you're going to take a derivative, just like the usual. Okay, and then you're going to set that equal to 0. So you set that equal to 0. And then you get your answer, which was 5. Okay, so for the geometry ones, remember how we're making the chart all the time? Okay. But like with geometry, it's kind of dumb making the chart because like when is my length going to be 0? Then it's not a rectangle anymore or whatever. So like we didn't really have to make one. Whereas this type of question, you have to, because you might make the most revenue when you don't have any price drop. Do you know what I'm saying? Because like if I only sell 60 for $90, maybe that's my maximum price. Like where I don't do any drops in price. So like this one's important that you do the chart, right? So we do the revenue because remember this is the price. I could have 0 drops in price, okay? So then I want to figure out what my revenue is. So that'd be 60 times 90, right? Because X would be 0. So I'm going to do the 60 times, no. Ugh, hold on. It just crapped out on me. This one, because at 0, you're not going to be able to get your, like a minimum. You need like an absolute max for this. So, like I was saying, like yesterday we did the geometry, like you could check with a sign chart to double check it's a maximum and you didn't do anything dumb, you know? But your answer should end up being like your max. But like this one, this would be an endpoint technically because it'd be no price drop. So then that's when you're going to do the 90 times 60 or 60 times 90, whatever, and you get $5,400. Okay. And then you would check your critical value, which is 5, and that's where you're plugging it in, remember, into this thing. So you would do 60 plus 12 times 5, then 90 minus 6 times 5. And this ended up being the 7,200. Okay. Now your endpoint, I mean, your other endpoint would be if you kept dropping price and you made no profit. Do you know what I'm saying? Like if you kept doing, like your end would be if I kept dropping the price by $6 and it was free. Do you get what I'm saying? So like this one, technically, what would that be? If it would started at $90 and then I kept doing $6 off all the time, that would be 15 price drops. But you get what I'm saying? Like it's free then. Then it doesn't like work. So this is like kind of stupid. So I would just make sure that for this type of question to check this endpoint because this could be actually where you make the most revenue. So that's the most revenue. What did they ask? Oh, for crying out loud. They asked for the price. Do you see that? How do I do that? Right? At what price? Okay, so where's the price? Oh, that's this blue one. 90 minus 6 times 5. So the sweet spot is at $60. So, well, that's what people do with trends. It's like you're optimizing your sales. So they look at trends for that and try to figure that out. It's very thing here. Okay, so I'm just going to do these two. These ones are weird because, well, you'll see. You have fish. The fish. Don't you miss the fish questions? Okay, fish enter a lake, modeled at that function. Fish leave the lake at that function. Look at that one. That's gross. Okay. Both E of T and L of T are measured in fish per hour, and T is measured in hours since midnight. At time T for 0 to 8 is the greatest. Greatest. See it? Greatest number of fish in the lake. Justify your answer. Okay. So we're not asking for a rate. We're asking for the greatest number of fish. Okay. What do you want to use for the equation? F. F for fish, hey? We'll use F for fish. I'm going to use time because, T is what they said. Total number of fish. So this one's weird because for step 2 is like when we like adjust it for the equation. But this one is weird because none of those equations are like the amount of fish. Do you get what I'm saying? They're saying rate. Rate. What the heck? You know what I mean? So I don't have like a normal function. What in the world? So, like, what am I supposed to do with this? F of t equals, I don't know. And then you guys might think, well, we could integrate. You haven't learned that yet, technically. So you can't do it that way. But, I mean, what's the goal of this thing eventually? Is to get a deriv, right? A derivative? Isn't that the goal? You want to get f prime, right? Isn't that the goal? You want f prime? Well, look what we got. We got stuff. We got rates. We have an entering the lake and leaving the lake. So is it entering the lake? Wouldn't that be E of t? Entering the lake would be the derivative, right? Minus leaving, L of t. So this is a weird one because you can like bypass this step because we kind of already have the derivative, which helps me get my maximum anyway. So what I'm going to do now is we're going to set that equal to 0 and do some tippity tapping on the calculator, right? So you're going to tip tap away, and I already did this in my head earlier. 6.2035, okay? And that's going to be that time. Okay. So now we get even sassier. Okay. Now, to justify that this is the for sure number of fish in the lake, you could look at your sign chart with those functions. Another way you could prove it is taking the second derivative and making sure it's positive. So another way you could justify this is actually the easiest way without a chart. Okay, it's going to be at that value, but the easiest way is you could use the second derivative test. If you threw in the second derivative of f, you would get negative 20.1962, which is obviously negative, which shows you that that's a maximum. Okay, so that's another way to show your greatest number of fish in the lake is doing the second derivative test on these. So the greatest number of fish, whoa! Number of fish in the lake is at t equals 6, no, t equals 6.2035. That looks like an F. Go away. Wait, what was the time on it? Hours, right? Okay. Okay, then the last but not least. Yeah. Yep. Exactly. Yep. Yep. Oh, you can't do the table because you don't have the F. Sorry. You can't do the table because you don't have the F. So I was like, well, shoot, what do I do? So you could do a sign chart or you could do second derivative test. Okay. Apple juice. This is cute. Okay. It is known that a prime of 9 equals 0, a double prime of 9 is about 12, and there's no other time on this day when a prime of t equals 0. Interpret this information in the context of the problem. Ready, go. You don't have to do much work. You should be able to say something. You should write a sentence. I didn't do any blue rates today, though.